Hi everyone. In this video, we will understand what is AWS KMS and what are different key types available in KMS. Then we will understand how envelope encryption is used for symmetric keys and how permissions and integration work with AWS KMS. Then we will create a mini project to understand symmetric encryption, and we will create a serverless password manager where you can store your passwords, and passwords will be encrypted and stored in DynamoDB. And then we will understand how asymmetric encryption works in KMS, and to understand it properly, we will create another mini project which is JWT Authentication Server. For KMS itself, we will start from scratch, but for making mini projects, it's good if you have understanding of how Lambda, Cognito, and API Gateway work in AWS. And if you're not sure, then you can check out my previous videos on AWS Cognito and Serverless CRUD app using AWS. So first of all, what is AWS KMS? KMS stands for Key Management Service, and it is used to create and control cryptographic keys in your AWS account. And those cryptographic keys can be used for encryption, decryption, or digitally signing and verifying signature. So if we see the definition here, it's used to create and use and manage your cryptographic keys. Use includes encryption and decryption, sign and verify. And management includes storing keys, rotating keys, auditing keys, and access control of keys, means who can use your KMS key. Similar to IAM, KMS is also integrated with many AWS services. So even if you have not used KMS directly, there are high chances that you might have used it while using some other services. For example, when we create S3 bucket, here we see what KMS key we want to use, and if we do not select anything, then this SSC S3 key is used by default. Before moving forward with KMS, let's understand some fundamentals of encryption. So encryption is the process of converting your data to some other form such that any unauthorized person can't understand it. For example, here we have two words, hello and world. We can use some key and some algorithm to convert into some random words, which if person don't know what algorithm and what key is used, they can't understand it. And in this case, key is that we are swapping each letter by 3. So if it's A, we are making it we are moving it by 3 and we are making it D. Similarly, if it's H, then we are making it K. Similarly for all letters. Now, this encryption can be of two types: symmetric encryption and asymmetric encryption. In symmetric encryption, same key is used for both encryption and decryption. One classic example is Caesar cipher, where each letter is swapped by certain digits. This is same example which we just saw above. And in this case, if we know what is the key, means by what numbers letters are being swapped, then we can reverse as well. So clearly same key is being used for encryption and decryption. For example, here we can see, here I can select what will be my key, means for how many numbers I want to shift, and here I am getting encrypted text for my original text. However, in asymmetric encryption, we use public-private key pair, which are cryptographically related for encryption and decryption. For example, in RSA encryption, for creating JSON web token, we can use private key for creating the signature and then public key to verify the signature. KMS supports both symmetric keys and asymmetric keys. Encryption inside AWS is mainly done using symmetric keys. For encryption outside of AWS, asymmetric keys are used. So based on structure, we have two types of keys, asymmetric and symmetric. Now based on ownership, we have three types of keys in KMS: AWS owned, AWS managed, and customer managed. Let's see detail of all these. So AWS owned is default key, which is used in most of services, and it is completely free. If you create a S3 bucket and if you do not select any encryption, then by default this SSE S3 is selected, and this is AWS owned key. This key is not visible anywhere in your account apart from this place, and it's completely managed by AWS. You have no control on it. There is no visibility on audit trail or key rotation. Another category is AWS managed keys, and these keys are also free. While creation of services, these keys appear as AWS/S3, AWS Lambda. For these keys, customers have visibility on key policy and CloudTrail events, and everything else like key rotation is managed by AWS. Also, policies are not editable. By default, AWS owned key is selected. If I select this option, here in dropdown, I can see AWS/S3, which is AWS managed key. I can also go to KMS, and under AWS managed keys, I can see managed key. For example, if I see Lambda, I'm able to see the key policy as well and cryptographic configuration also. Now, third and last category is customer managed key. And customer have full control on audit, rotation, and access control of these keys. Charge for these keys are $1 per month. And if you want to call KMS API from your application for encryption or decryption, then this is the type of key which you can use, because other two types, AWS owned and AWS managed, are to be used by AWS services only. Like S3 can use them to encrypt objects, or Lambda can use them to encrypt the code or environment variable. But we can't use these in our own application like Node.js server or Lambda function. Now, since these two are used by AWS services only, these are always symmetric keys. AWS owned and AWS managed will be symmetric. Customer managed keys can be symmetric or asymmetric because we create them, and we create according to our need. For more information on KMS key types, you can check out this documentation from AWS. They have all details here, especially this table, these two tables. Now we know that customer managed keys can be symmetric or asymmetric, and these keys can be used for these three purposes: encryption and decryption, like encrypting password, creating digital signature, like creating JWT and verifying it. And asymmetric key also have one more use, which is key exchange or agreement. So it's used to create a shared secret without actually sharing it, and used in initial handshake during HTTPS and VPN sessions. Data can be encrypted at these three places: at rest, while storing in the disk, like while storing in the S3 bucket; in transit between client and server, HTTPS or TLS is used to secure the data; and also in use while being used by a server. Coming back to our learning plan, these two key types are used by AWS services and nothing much to understand about them. In customer managed keys, we have symmetric and asymmetric keys. So let's first understand customer managed symmetric keys, and then we will understand customer managed asymmetric keys as well. For customer managed symmetric keys, KMS uses envelope encryption, but let's understand what is the need of envelope encryption here. So imagine you have million of files or objects to encrypt, and you have symmetric key, means you will use same key to encrypt and decrypt both. Now if you encrypt all objects using same key, and somehow key got compromised, then all your objects are compromised, because same key can be used for decrypting all of the objects. Another thing you can do is you can keep separate symmetric key for each object, but problem with that approach is that it's not scalable, because in that scenario you have to manage 1 million keys, which is a big overhead. Before going through how envelope encryption solves these issues, let's go through this example. Suppose I want to give a box to my friend, and I don't want him to open the box without my permission. So what I can do, I can lock the box and give both key and locked box to my friend and expect that he will not open it. But still he might open the box, or even he might lose the key and someone else can use that key to open the box. Another thing that I can do is that I can lock the box and keep key with me, give only locked box to my friend. But this scenario looks good for single person. Suppose I have 1 million person, then I have to keep 1 million keys with me and also keep them secure, which is a big headache. Now, to solve this problem of sharing box, I can use envelope encryption. So what I can do is that I can lock the box using key like previous scenario, but this time I can encrypt or lock the key itself using my own super secret key, which I keep in maybe in some super secret place, and then I can destroy the original key which I used to lock the box. Then I can give this logged key and locked box to my friend, and he will not be able to open the box. Whenever he want to open the box, he have to come to me and ask to unlock his key so that he can open the box. And I can do this with all of my friends. I have to just keep my super secret key secure. Now let's go to definition of envelope encryption. In envelope encryption, we encrypt the message or object using a key. Also, we encrypt the key using some super secret key. Once we have encrypted message and encrypted key, we discard this original key and store just encrypted key and encrypted message together. Later, when we want to decrypt, we can again use this super secret key to restore this original key and unencryptable message. Coming back to definition. So in envelope encryption, key used for encryption of plain text is encrypted or enveloped itself by super secure master key, and then both encrypted message and encrypted keys are stored together. And this helps to achieve centralized key management and auditing. Now let's see how envelope encryption solves the problems which we discussed initially. So the first problem was that if we use same symmetric key for all objects, then all objects are in danger. But if we see a diagram here, for each object we can spawn this key and use separate key for each object. Another problem was that if we use separate key for each object, then in our key store we have to store all those keys and secure them. And that was a big problem for scalability. But if we see here, just after encryption, we are discarding this key and using super secret key to create encrypted key, and encrypted key stays with the object. So if object is encrypted and stored in S3 bucket, then encrypted object and encrypted key will be stored in S3 bucket. In our KMS service or in our key store, we have to only store our super secret key. So this solves the issue of scalability as well. Now let's see how AWS KMS achieves envelope encryption. So first step is creation of key. So I will just quickly We will do this again, but for now I will just quickly create one key with everything default. And here we created a symmetric key. So when we create this key, what happens is that AWS HSM or hardware security module creates one key which is called HSM baking key or HBK. Now this device will be used by other customers as well, and this HBK can't always live inside this module. That's why this HBK is encrypted and stored as exported key token or EKT in some durable storage. Point to remember here is that this HBK is actually the super secret key which we talked about earlier. Now it's exported and stored as EKT. Also, the key which we have created in KMS console, it do not contain actual key material. Instead, it just contains a pointer to the EKT. So this key which we have created here, it will not contain any actual key material. Actual key material is at EKT and it's just a pointer. Now step 2. Suppose we want to encrypt some message. So this will be the workflow for that. And this workflow happens when we make generate data API call to AWS KMS. And when we make this generate data key API call, we either pass alias of key or ID of key, this thing. And this key, we know that it is pointer to exported key token. So exported key token is taken and sent to AWS HSM. Then AWS HSM decrypts EKT to restore HSM baking key, which is our super secret key. And then this super secret key is added with some random number or nonce, and a new key called derived encryption key or DEK is created. Also, this HSM only creates another key called data key, and this data key is encrypted using this derived encryption key. Now at this point we have data key and encrypted data key. These are returned as part of generate data key API call, and object is encrypted using this plain text data key or data key. Then encrypted object and encrypted data key are stored together and plain text data key is discarded. So at this point we have encrypted object and encrypted data key in our disk. In step 3, which is decryption process, we have encrypted data key and encrypted object, but we can't use encrypted data key to decrypt it. For this, we make decrypt API call, and as part of decrypt API call, we send encrypted data key, and this data key contains information regarding nonce. This nonce which was used to create derived encryption key, and it also contains information regarding which KMS key was used to create this data key. So from that information EKT is recovered, and from EKT HBK is created. Since we have nonce again, we can create DEK again. Once we have derived encryption key, we can decrypt data encryption key, because if we see here, this derived encryption key was used to encrypt data key in first place. So again we can use it to decrypt, and then return data key. Now we have data key in plain text, and it can be used to decrypt our object or message. So what's important here is that we can see the actual key, SBK or DEK. These are the main keys which are being used to create data key, and they never leave HSM module in unencrypted format. Also, for each generate data key API call, data key is created and returned, but there is no need to store information regarding this in the KMS. So that helps in the scalability part. Also, each time we want to decrypt the object, we have to make this decrypt API call to KMS, and hence each decrypt operation can be audited. Now let's go to AWS console and perform hands-on for envelope encryption. So step 1 is creation of Asymmetric key. Go to KMS dashboard and navigate to customer managed keys. Click on create key. Under key type select symmetric, and we are going to use for encrypt and decrypt. We can also select origin of key material. If we use KMS, it will use KMS HSM module. However, we can also use dedicated cloud HSM module or external options. But for now, let's go with KMS. By default, KMS key is single region key, but multi-region also available. Then put some alias. Let's call it learn. And it helps to decouple your application code's logic from KMS key lifecycle. So one key can have multiple alias, and same alias can be reattached to another key also. So for now, we are giving this key as a learn alias. Later, if we want, we can delete this key and use same alias with some other key. But in code, once we code learn alias, we will always use learn alias. Then click on next, and it will ask to select key administrators and then key users. For now, let's not select anything. We will come to permissions later. Click next, and then this is the default key policy. Default key policy grants all KMS actions to the root users. What it means that now AWS IAM can be used to add access for this key to any user or role. Click next, review and finish. Now we have this new key with alias as learn. Since I am logged in as admin user, my user have all access to this key. Coming to this workflow, step 1 is done, key creation is done. Now to perform envelope encryption, we need to call generate data key API and get plain text data key and encrypted data key. So let's do it. For AWS CLI commands, instead of installing AWS CLI locally, let's use this CloudShell. Since I am logged in as admin, in CloudShell also I will have those permissions. And for commands, you can check this GitHub repo. Right now, code is not here, but I will add it later. For now, let's take it from this blog post. Let's go to CloudShell and generate data key. But before that, let's create a text file that we will encrypt. So I will use nano test.txt and let's put hello KMS in it. Then ctrl plus o and ctrl plus x. So this is something similar to what happens when we upload object in S3 bucket. So when we upload object in S3 bucket, what happens in S3 server is that it generates data key, it encrypts the object, and then it keeps encrypted object and encrypted data key. Something similar we are going to simulate here as well. Now I have my test file. Let's create data key, and this is the syntax. AWS KMS generate data key, then key ID and key spec. So for key ID, either we can pass like key ID and this thing, or we can use alias. So when we use alias, we have to put like this alias slash whatever is alias name for this key, and then output is saved in data key.json. Let's hit enter, and then do cat data key.json. Here we can see that we have plain text and ciphertext blob. So this ciphertext blob is encrypted data key, and this plain text is data key. If we see here, so this is encrypted data key, this ciphertext blob, and this plain text is data key. Now let's run these two JQ commands to put these keys in their respective files. There is typo. It should be like this. So what these two JQ commands are doing is they are reading data key.json, and from there extracting data key plain text from plain text, and then data key encrypted from ciphertext blob. Now since we have both version of data key available, we can delete data key file. At this point, we have plain text data key, encrypted data key, and our unencrypted test file. Now let's use OpenSSL utility to encrypt our file from here to here. And what it is doing is that it's taking input as our test.txt, and it will give output as test.encrypted, and password is taking as data key plain text. Let's hit enter, and now we have 4 files: plain data key, encrypted data key, plain text, and encrypted test. Now at this point we do not need test.txt, which is an encrypted text, and also we do not need plain text data key, this one. Now from a S3 perspective, at this point we can store these two in the disk, and things are done until we want to receive our text back. So we are done with step 2, that is envelope encryption. We successfully encrypted our text. Now let's see how to do decryption. So for decryption, we can use data key encrypted, and from data key encrypted, we will get plain text data key that we will use to decrypt test.encrypted. And I forgot to show content of this, but right now it's looking something like this, which means nobody can read that it's hello KMS. Now let's call decrypt API to decrypt our data key. And this is the command AWS KMS decrypt. In ciphertext blob, we have to pass our encrypted data key. In output, we want plain text, and we have to pass region as well. Then we will do base 64 decode and store it in data key plain text. Let's hit enter. And here I got error that this resource do not exist in this region, and reason behind this is that right now I'm in US East 1 region, and here I passed AP South 1. So let's correct it. US East 1 and hit enter. Done. Now we received our data key plain text back, and this step is done, means all this is done. We passed our encrypted data key. AWS HSM recovered HBK and nonce and HBK created data encryption key, and then data encryption key decrypted our encrypted data key, and as response we got our plain text data key. Now since we have plain text data key, we can use OpenSSL utility to decrypt our encrypted message or text file. Let's run this command as well. And here if we see, it's taking input as test.encrypted file. Output it will give test.decrypted.text, and password it's taking as plain text data key, similar to last time. Here we got new file which is test.decrypted.text, and if I try to read it, we got hello KMS. So we successfully performed envelope encryption and decryption, and something similar also happens in AWS S3 bucket when we upload objects in it. Now, one more thing is that if we have a small text file or object that we want to encrypt and its size is less than 4 KB, then instead of doing generate data key API and then encrypting using OpenSSL, we can directly call encrypt API and pass our file as input, and it will return, or KMS will return encrypted file to us. So it's like these steps still will be performed, but KMS will handle it. So let's try that also. Here only I could have done encrypt API call from beginning, but I just wanted to demonstrate how generate data key API works. For now, let's remove everything from here. And let's create new file. Let's put I am small than 4 KB, CTRL plus O, and then CTRL plus X. Then copy this command. And command is AWS KMS encrypt. Then again we pass key ID, and this time we are passing our plain text as well, which is myfile.txt. Output we want text, and query we are doing ciphertext blob. Region we want AP South 1. So let's remove from here and all the way to here. Let's see what happens if we do not pass query as well, and I will correct region this time. It is US East 1. So this is the output that I got, and it contains this big encrypted text and KMS key ID. So to get in proper format, we pass query as well, and when we pass query as ciphertext blob, then we will just see encrypted text like this. This symmetric default and this extra key ID is removed, and then we can save it to file.encrypted. So let's copy and append this at the end. Enter. Now I have new file which is myfile.encrypted. Let's see its content. This is the content. Now let's decrypt this file, and for decryption we will use decrypt command similar to last time, but here instead of sending encrypted data key, we will send encrypted file itself. Again I will correct the region. and enter. Error is there. Let's run this much only. I got this, and then it's giving error base 64T. Let's try base 64. I don't have any code here. Okay, so looks like there was issue in copy pasting. Now it's working, but with -d only, it not worked. Let's try again. It's working. For some reason, when I copy pasted, it gave error, but now it's working. So that's how AWS KMS handles envelope encryption. Now let's see how AWS KMS can be used with S3 bucket and Lambda function, and also try to understand how permissions work in AWS KMS. In this section, let's understand how access control works for KMS. For each KMS key, we have a resource level policy called key policy, and here we can define what entity can perform what actions on this key. And by default, we have this statement added to key policy. It looks something like this, and it allows all KMS actions by the root user for this particular key. Resource is star here, but since this policy is belong to this key, so this star means this key here. And what this statement means that since all permissions are given to root user, it delegates access control to IAM as well. So now we can manage our access control at two places, one at this level, at key policy level, and also at IAM level. So for example, I have some user named test user, and I attach this IAM policy to that user. I attach that I want generate data key access to name, suppose I attach for this key. So then that user will be able to make generate data key API call for this KMS key. Also, if I want, I can give same access at this key level by doing something like this. I can add one more statement in key policy and say that I want test user to perform these KMS actions. So in short, for a KMS key, we can manage access control either at key level or at IAM level. Now let's go to AWS console and see this KMS policy in action. So this is the key with alias as learn which we created. And since we not added any key administrator or key user, or in other words, we not added any statement, that's why our policy have only default statement, and it's delegating all permission to IAM. So right now we are at this position. So first of all, let's create new user and add policies to that user and see if and see how things work. In IAM, I have two users, admin user, which have admin privileges, means it have full access for all keys, and then this test user, which do not have any permission as of now. Let's create a KMS encrypted S3 bucket and play with policies. So I will go to this test user and add full S3 permissions. Also in this version of Firefox, I'm logged in as admin user, and in this incognito mode, I'm logged in as test user. So I'm here in S3 bucket. Since we have admin permission for this user for S3 bucket, we can create new bucket. And here let's call it my KMS bucket. And for encryption, we will use KMS encryption. So I will select SSE KMS and choose from your AWS KMS keys. But when I try to select KMS keys, it says you do not have permission for list KMS keys for this test user. That's why it's not able to do it. It's not able to show me KMS keys here. So let's add one inline policy here for KMS keys. And for action, we want to list aliases. And for key, okay, for key, list alias support all wildcards. So let's give it KMS policy, and we will keep coming and keep editing this policy. Again, if I refresh here, this time I should see keys. And here I will select learn key and create bucket. Now, what will happen here is that whenever I upload some object to this S3 bucket, that object will be encrypted by this key which have alias named learn, this one. And for that, envelope encryption will be used, means it will make generate data API call. But since our test user do not have generate data API action or that permission, it will not be able to upload anything to this bucket, even though it have full permission to S3 bucket. So I will upload this test.txt and upload failed with error access denied, because S3 can't encrypt this object. Now let's again go to KMS policy, which is inline policy of our test user, and let's add one more statement here, and this will also be for KMS, and this time we want for generate data key API call, and for resources I want this resource. So key, and I will paste ARN from KMS add resource. Now our user can do generate data key API call for this key which have alias as learn. Let's save the changes, and now let's try to upload it. This time it will work because we have generate data key API permission for this user. Here looks like I added .txt 2 times, but now if I try to get this or download this, that will not work because I do not have decrypt permission. Let's try to open it, and here I will get access denied. Similarly, if I try to download, then also I am not able to download, because in envelope encryption we saw that I will again go to the diagram. So yeah, in envelope encryption we saw that first generate data key API call is made to encrypt, and for decrypt we make decrypt API call. So let's go to IAM role where I'm logged in as admin, and again edit our KMS policy for test user. This time in this block only I will attach one more action, which is KMS decrypt, and save it. Again, let's go to S3 bucket where I'm logged in as test user, and now if I try to open it, here I'm able to see the content of my file. Similarly, I can download also. So what application here is that suppose we want user A to only upload the file and user B to only download the file, then we can put only this policy or this action in user 1 policy and this in user 2 policy. Till now we added permissions at IAM level. Now let's see how we can add permissions at key level. So for that I will use same user test user, and let's remove this KMS policy, and this time let's use Lambda function. So I will attach Lambda full access so that this user have permission to create Lambda. And let's refresh the page. Now let's create a function and let's call it KMS test. Everything else keep default, but in additional configuration, let's use AWS KMS customer managed key to encrypt the Lambda code. So this is especially useful when you want someone to do Lambda specific operations, but you do not want them to edit code of your Lambda function. Then in that scenario, we can encrypt code of Lambda function. Now here you might be thinking why this user is able to list KMS keys or KMS aliases even though we removed KMS policy for this user. So if I go to IAM dashboard, I do not have a KMS policy anymore, but I have this AWS Lambda full access, and for this Lambda full access, KMS list aliases is attached to this user. That's why I'm able to list all the alias. I will select learn, but it is failing. You don't have permission to describe key. So I can list the available aliases, but for this particular key or for this particular alias, I do not have describe key permission that we need to add. Let's go to KMS key policy, and here add one statement, and action we want describe key, and we need to add principal also to tell which user we want or which IAM role we want to do describe key. So add, and I want IAM user, then go to test user, copy ARN or Amazon resource name for that user and paste here. Save the changes, and now refresh it, select learn. It will not work. We need to refresh, and for keys select learn. We will not see any error. Create function. Again we got error. We do not have permission to create IAM role. Okay, let's go to IAM role again and add permission. Let's see if there is something for role or IAM read only. For now, let's give IAM full access to this user. Again, I need to refresh. Now, again, it failed, and it is saying that this user do not have permission for generate key, because when function is created, the default code of function, it tried to encrypt and failed at that step. So let's go to KMS key policy and edit policy again. This time, here only, let's add one more policy. Get data, not get, generate data key, and save changes. Again, we need to refresh. Now I will call this KMS only and select key, and hopefully this time it should create. It failed again because I do not have decrypt permission. Again, let's add decrypt as well. Now, this time issue is not that our user do not have necessary KMS permissions, but instead this Lambda service itself do not have KMS permission for this. So let's go to KMS policy, edit the policy, and add one more statement. This time we want to add generate data key and decrypt. And for principal, select AWS services and select lambda.amazonaws.com and add. So now we have this default statement, statement to add permissions for our test user, and also a statement to allow lambdas to use these actions or call these APIs. Now save changes. This time functions should be created, and here function is created and it's encrypted by this KMS key, and I'm able to see the code because I also have permissions. So let's go to KMS key again, and this time let's remove decrypt permission for test user. Save changes, and now if I refresh, I will not be able to see the code. Ideally, I should have seen that I do not have decrypt permission as well, but looks like because of some browser specific issue, I am not able to see here. In Chrome, I was able to see that for my user decrypt permission is not here. That's why I'm not able to see the code. Now let's do one more thing. Using our admin user, navigate to Lambda console. And right now we have encrypted the code. Let's create some environment variables and encrypt them as well. So I will go to environment variables. This step I could have done using incognito also, because there also I have generate data key permission, but let's do from here only. And for encryption, I will use customer managed key, save the changes. So here as admin, I'm able to see the environment variable but as test user, I should not be able to see. Let's go to configuration and then environment variable. Here, I'm not able to see the environment variable because decrypt permission is missing for me. So that's how we can use key policy for KMS to access control. Coming back to policies, we can edit policy like this by editing JSON, or we can also add administrator and key users directly using UI. But since for this key I have edited, those options are not available. Let's go back to CMK dashboard and I will select this key, test key, which I created initially. Here I'm creating many keys, but when you create in your account, make sure to create only what is required because these keys are chargeable. And here I was talking about these two options, key administrators and key users. So what we can do, instead of switching to policy view, we can add here only. So I will add admin as key administrator. And what it will do is that if I show in policy, it will add admin user with these permissions. And these are administration related permission. Like we can see, we have delete, we have describe, but we do not have encrypt or decrypt. So for administrator users, administration related policies are added. For key users, I will add test user as key user. So for key users, these encrypt, decrypt, and generate data key APIs are added. So here, allow use of key, and these actions are added as part of key user. Also, as part of key user permission only, these policies are also added, which allow to grant this key to some other user. So suppose I have one more user as user 2. So we can make AWS KMS grant API call to grant access to this KMS to another user for some time. Hi everyone. In this video, we will see how to use KMS customer managed keys with secret manager. So first, let's create a symmetric key and let's give it alias as key for secret and create with default policy. Now let's go to secret manager and store a new secret. I want key value. So let's put some random value here. And for encryption, I can select my key which I just created, which is key for secret. And since I'm using this key for this secret, only if user or entity have permission for that particular key, then only this secret will be available. So next, and let's call my secret and store. Now here I have some code sample, but I will use console only for retrieving the secret. So since I have administrator permission for this user, I am able to see the secret value, which is test123 here. Now suppose there is some another user which have permission for secret manager. So here I have user named test user, and it have secret manager read and write permission. But since this user do not have permission for the KMS key which we just created, it will not be able to access the secret. So if I refresh it, here I can see that I have secret named my secret 123. Also, I am logged in as test user in this incognito window. And if I go to my secret 123, and if I try to retrieve secret value, here I am getting the error failed to get secret value. And here if I see in the API call response, error is access denied exception, access to KMS is not allowed. So this is how we can protect our secret using KMS key and restrict only to certain users. Now let's grant access to this test user and see if it works. So I will go to customer managed keys and add a key user. Let's add test user. And now if I refresh this page and again try to retrieve the secret, it is working for me because now this user have permission for that key. So this is how we can use KMS with secret manager. Now we know that for this learn key, our test user do not have decrypt permission. So here our test user do not have decrypt permission. That's why we are not able to see environment variables in Lambda function. So let's use KMS grant to grant decrypt permission to our test user. So I will open CloudShell, and also let's open AWS KMS grant and go to command reference, CLI command reference, scroll down, and somewhere we have example here. So this is syntax: AWS KMS grant, then key ID, and then grantee principal means to which user we want to give that particular permission. Operation, we also want decrypt. Constraint, we do not need. Retiring principal, so here we can pass ARN of that user which can basically nullify this grant. Let's go to our CloudShell and paste this one by one. Here I am logged in as admin, so I have admin permissions. I will make it big and paste AWS KMS Key Grant and key ID hyphen key ID. I want this ID with learn alias, so from here to here, and then to which user I want, so paste it, and I want for this test user. Let's come to new line, and then we want operation decrypt and enter. Here we got grant ID and grant token. Grant ID we can use at any point of time to basically revoke the grant, and I can give this grant token to the user whom I have given access. Now let's go to Lambda dashboard where I'm logged in as test user, and let's refresh and see if I can access it or not. And here I'm able to access environment variables. Similarly, I should be able to see code also now. Yeah. So that's how grant work in KMS. In your case, if you do not see the environment variable and code even after successfully creating grant, make sure to wait for 5 to 10 minutes because it's eventually consistent and takes some time. And now we can run AWS KMS list grants, and then we can pass key ID, and we can see active grants for this key. Here we can see list of all grants, and I can see total 3 grants here. This one, and this one. The grant which we created was ending with 1F, so 1F. This is the one which we created for test user. Now let's revoke the grant. So ctr plus c and use command AWS KMS revoke grant. Then for which key we want. So it's this key ID, and then we need to pass grant ID as well. So this is the grant that we want to revoke. Pass grant ID and hit enter. It's revoked now. If I see list, I should not see this 1F. Let's see. Okay, now I see 2 grants. Earlier there were 1, 2, and 3. So yeah, now this grant is removed. Let's go back to Lambda function and refresh it. Now I'm not able to see the code and also environment variable. Now let's see how auditing works in KMS. One of the benefits of envelope encryption that we discussed was centralized auditing. That is, for each encryption and decryption operation, we make call to KMS and each operation is audited or recorded somewhere. So let's see how we can see this record of API calls in AWS. So navigate to AWS console, and I will close this test user now. It's not required anymore. I'm logged in as admin, and let's navigate to CloudTrail. Under CloudTrail, go to event history and select resource type as AWS KMS. Here we can see all management events like rotate key and create key, list aliases, and all that. For seeing data events like making generate data key API call or encrypt API call, we need to select event source and select aws.kms or kms.amazonaws.com, and here we can see all the API calls which we had done. So these are generate data API calls, these are decrypt API calls. Basically everything will be shown here, and it includes both data and management events. Let's see this decrypt command, and here if we see, it shows the time when this command was made, which user made this command, and what was the source. So if we use AWS CLI to make these API calls, or if we use our own computer, and we will see actual IP address. But just now, while seeing demo of permissions, we used Lambda functions. That's why we are seeing Lambda function as source here. And there was some issue with permission. That's why, because for test user, decrypt permission was not there. That's why error code was access denied. And all other details are available as part of this JSON data. Here we can see error as well. User is not authorized to perform this. And this is the exact message which we saw in the AWS console in last step. Now I will scroll down to find API calls which we made for envelope encryption. And here I remember I made that call on 6th April. So let's select 6th April. And here, these are the calls. So if I go here, generate data API key, I used CloudShell using admin user to make this call, and that is recorded. Notice this starts with 10, means looks like this is the private IP of instance where CloudShell was running at that time. Till now, for symmetric keys, we understood what is envelope encryption and how it is done with AWS KMS CLI commands. Then we saw how permissions are managed in KMS, and same rules apply for both symmetric and asymmetric keys. Then we saw how symmetric keys can be integrated with services like AWS S3 and Lambda. Now let's create a mini project which is a serverless password manager. And this is the architecture. So here we have a DynamoDB table which will store our passwords, but passwords will not be stored in plain text. Instead, when we make API calls, API gateway will talk to Lambda functions, and Lambda functions will talk to KMS service, and then passwords will be encrypted and stored in DynamoDB. Regarding schema, so this is the schema. We have user ID. For each password, we will have password ID. Then we can add site name, username, and password. Same user can have multiple entries, and user ID is partition key here, password ID is short key here, and these two will form composite primary key, and combination of these two will be unique value in this table. And then we have React frontend and API gateway. Both are configured with Cognito, which will provide user management for our application. In fact, here the user ID which we are storing, it's nothing, it's just user ID provided by Cognito. So let's go to AWS and do the setup there. Close all this and open this GitHub repo, AWS KMS Course. You can either open with GitHub desktop by making fork, or just download the zip and then extract the content and open it in VS Code. So open this location in command prompt and then run code dot, or you can open VS Code and open this folder. Now here we have this folder password manager, and here we have code for Lambda and frontend with auth, means React frontend. One more thing, here we will run our front end locally. We will not upload it to S3 bucket and CloudFront to keep our focus on KMS. If you want, you can check out my previous serverless video to understand how to do that. So let's start from this left side, DynamoDB, and go to tables, create new table, table name. Let's see what I'm using in the code. So in code, I'm using table name as pass manager. Let's keep same name here as well. And partition key. So partition key is user ID, which will come from Cognito. And then we have sort key as pass ID, and both will be string, and the combination of these two will be a unique identifier. Everything else leave default and create table. Now we need to create a KMS key and Lambda functions and API gateway. So let's create a KMS key, which will be symmetric key, and we are using it for encryption and decryption. KMS will be source of key material alias. So we will use alias as password manager key, and then no need to select anything here. Click next, next, and with this default statement, create the key, and this is our key, pass manager key. This is the alias. Now let's create one role, because we have these Lambda functions, and we need some IAM role to talk to DynamoDB and KMS. Go to IAM role and create a new role. Let's create a role for Lambda, and here let's give it Lambda basic execution role, which will allow to create CloudWatch logs, and let's call it pass manager role, and this generic role we will use for all Lambda functions. Inside pass manager role, let's create two inline policies, one for DynamoDB, and we want get item, put item, delete item, and update item. Also query. For which table we want, so we want for pass manager table, copy its ARN and paste here. Next, let's call it Dynamo policy and create the policy. Let's add one more policy as KMS policy for generate data key, encrypt and decrypt operation. And we want for this pass manager key. Next, policy name, let's call it KMS policy. Now role is also created. Let's create these Lambda functions, and before that, let's review the code of each Lambda function. So here, let's start with create password function. So in create password function, we will take username, site name, and password from body. User ID we will take from request context, and since we will use API gateway with Cognito, this user ID will be available as part of authorizer.jwt.claims.sub. To check it, you can just create a Lambda function and log the event and expose it by API gateway and attach Cognito authorizer, and in the logs or in the response you should be able to see this format. Now if these details are not present, then we will return error. If these details are present, we will call encrypt API to encrypt the password. For that, we will pass key ID, password, and encryption context. Notice that we are not using generate data key API here, because size of password will be less than 4 KB. And even here I added generate data key, but it's not required. So let's remove it. Only encrypt and decrypt will be sufficient for us. Save. So password we encrypt, and then we store encrypted password in DynamoDB with other details. Also, let's correct region. So right now I am in US East 1 region, so we'll create resources there. Let's correct it in all places. So get delete do not have and update. Now coming to code of get password function, we have two parts. So if it's like example.com/pass only, we are returning all passwords for that particular user, but we are not decrypting them before returning. And it will be used in home page where we will show cards of all passwords, but not the exact password. Inside if block, we have code for example.com/pass/password ID, and this time we will get that particular password ID and decrypt it using decrypt command by calling decrypt API of KMS and return decrypted password. And this will be used, suppose we have multiple cards on home page. If user clicks on some card, new page will open with decrypted password. Also, while decrypting and also while encrypting password, along with key ID and password, we are also passing encryption context, which is like context provided for encryption or decryption, and we can pass key value pairs here, and whatever context I pass during encryption must be passed during decryption also, else API call will fail. Now let's see code for update. So for update, I guess I made some mistake. Let's check again. So forget region is, it should be US East 2. It looks like I copy pasted wrong thing everywhere. Update. So in code of update, we are taking new password from user, and then we are just encrypting and updating DynamoDB table. For delete, there are no KMS call involved. We are just deleting the entry from DynamoDB table. Now let's deploy them. So I will deploy manually while creating function, and before that I will create zip of all these. So let's navigate to the folder, cd password manager, lambda, and run this script. It will just go to all folders and create 4 zip for me. So let's run it. So I will go to lambda and create new function. Let's call it get pass and select ARM64 as architecture. Select pass manager role which we created and create function. Now for each function we will create function, upload the code, and also update index handler. Upload the zip file. Also, since in our index.html our main logic is in get pass, that's why we need to update our entry point as index.getPass in handler setting. Now let's create one more function as create pass, and as name suggested will for post call. Let's select a role, create function, and let's upload as zip file, save it, and also edit the handler. I will go to function to make sure it was the correct function name, and instead of handler I want to call create pass function. Go back and create update pass IAM role and upload zip file for update function, and also let's update handler. So for update it should be update handler, update pass. So let's copy it. One more, and the last one, it's delete pass, and again select the role. Let's copy its name also. It's straightforward, delete pass. Let's update the handler and also update the code. Now we have all our Lambda functions in the place with required IAM role attached. Also make sure to update handler in each of them. Let's create API gateway now. So I will open API gateway and create new HTTP API. Let's call it pass manager API gateway. Everything I will leave default, and then I have to create total 5 routes, 2 for get and then for other 3. So for get, let's create get route, and it is pass, which will return all the password for that user, and then we have /pass/id, and this will return decrypted password for this password ID. Let's create post also, and it will be just pass and data will go inside payload. We need put for update function, and we will pass with ID which password we want to update. And last one is delete. We need to pass ID and also /pass/ID. Now we have all the routes in API gateway. We need to configure Lambda function for each of them. So for that, let's go to integrations and create and attach integration. So first one is get pass. I will create one Lambda function with get pass and attach. For this one also, same Lambda function or same integration can be used. So I will attach it. For post, I will create new integration, and this time I will select create pass as Lambda function. For all, make sure to keep this on because it will add permission in our Lambda function so that this API gateway can invoke it. Now, similarly, let's create for put and delete. So put will use update, and delete will use delete function. Now for each route, let's attach authorizer, and we will use Cognito authorizer. So let's go and create a new Cognito user pool. To user pool, create new pool, create for single page application. We need email for sign in and sign up. Return URL localhost 5173 because I will run client locally. Create directory and skip this overview. Here we have token signing key URL. So what happens in Cognito is that it uses OAuth protocol for hosted UI, and this link exposes public key for verification of tokens issued by JWT tokens issued by Cognito. In later section of this course, we will create something similar. That's why I showed it here. So what we need to do, we need to copy this URL and tell our authorizer of API gateway to use this URL for verification of the tokens that we will pass as authorization header from client. Remove this till here. Also, we need to configure our audience, and inside token audience will be client ID. So add audience client ID, and let's call it auth and create. Let's go and attach this authorizer to all our routes. So all 5 routes we need to attach. Done. Now at this point, one thing we can do, use Postman and call each API, and for calling each API use token from Cognito by going to login page and then getting the token. Else we can use frontend because we have to make very small changes in frontend to use it. So let's do it frontend only. And in frontend, I have these 3 main files: app.jsx, not app.jsx, home.jsx, where I am calling all passwords like example.com/pass API and showing cards of all passwords with site and username detail. On click of any password, this item details.jsx will load, which will show unencrypted password or decrypted password by calling /pass/password id. Here only we have feature for edit and delete API call also. And for each API call, we are reading this access token from session storage and attaching to the API calls. And the library which we are using, they will take care of OAuth flow and storing the token in session storage. For more details, you can check out Cognito video. For now, let's proceed. So I will go to this folder, cd frontend, and install dependencies. Till dependencies are installing, we need to update main.jsx and app.jsx. So in main.jsx, let's go to Cognito overview and quick setup guide for React and copy as it is. These are the configurations that will be used for that library. Is React IDC context for carrying out the OAuth workflow. One more place we have to update is this thing inside app.jsx. This one. Also here we need to update logout URI, which we can keep for now as home page. And also we need to update it here in login page settings as sign out URI and save changes. Let's run our application. And before we run our application, we need to update course setting as well. Else what will happen? Our API calls to API gateway will fail because of course error. So what we can do, we can go to course setting of API gateway and add localhost 5173 to allowed origin. Make sure to remove slash, and here we can add content type, means what headers we want to accept. We are also sending our token as part of authorization header. So add that as well. Methods get, post, put, delete, and save. Now let's go to our application and sign in. We need to create a new account, get the code from email and confirm account, and it will log in. Here it's calling wrong URL. Let's see what is the reason. I guess I have not updated environment file, so let's update it. Let's make it .env, and here we need to update API gateway URL. So go to API gateway and copy this invoke URL and update it here. Now let's remove this and hit enter. This time it's making call to API gateway and it's successful. Let's add something. So I will add aws.com and username, let's call test, password, let's add something and add. So here I got 201 response and it's successful. Let's add a few more. So now let's click on one of these cards and here I got undefined for something. Let's see. Not sure, for some reason password ID is undefined here. Let's go back here, clear it and click again. This time we have password ID, and for this password ID we got this password, and let's edit it. Let's add this attend and save it. So password is updated as well. Now let's delete it, and it got deleted. Now let's go to DynamoDB table and see how things are looking there. So go to table, explore items, and here we can see we have 2 entries, and this is the password which is stored in DynamoDB, which is in encrypted format. I think it's very big, but this is envelope encryption, and it contains information regarding both my password and the key which was used to encrypt it. Coming back to architecture, we have our working password manager, and right now I'm hosting React locally, but we can put this React to the S3 bucket and expose it with the help of CloudTrail CDN. Also, API gateway can be exposed with the help of CloudTrail CDN. We are done with symmetric encryption. We understand what it is and saw its demonstration and project. Now let's see what is asymmetric encryption or asymmetric keys in KMS. So we have already seen that in asymmetric key, we have 2 keys, private key and public key, and both are mathematically related to each other. Also, in AWS KMS, for asymmetric keys, private key never leave KMS, only public key is publicly exposed. So let's go to KMS console and create one asymmetric key and use it to sign and verify a JWT token. And commands can be found here. So in a GitHub repo, I have added all commands for symmetric encryption, key grant, and asymmetric encryption. Asymmetric encryption to create a JSON web token. So you can find it in the repo. Now let's create a key. Let's get asymmetric key. And asymmetric key can be used for 3 purposes: encryption, decryption, sign and verify, and key agreement. And in all these scenario, only public key is available to be shared with others. So in encrypt decrypt, public key will be shared, and clients will use public key to encrypt something and send to S3 or send to AWS. For sign and verify, signature will be created with the help of private key, and verification will be done with the help of public key. And in key agreement also, only public key is available to be shared. I have not explored this option much, but for now let's select sign and verify, because this is what used to create JWTs. For key spec, let's select RSA2048, and advanced options, let's keep default and create our key. For alias, let's call it JWT key, because we will use for creating JWT. And administrator and user, let's not select anything. Default policy is sufficient for admin user. And finish the creation of key. Now if I go to JWT key, under cryptographic information, I can see it's a symmetric key and purpose is sign and verify. In public key, I can see my public key, and this is the key which we can expose somewhere, maybe some public endpoint we can create, and we can expose it so that the tokens which we create can be verified. Now let's open CloudShell and use AWS KMS CLI commands to use this key and create a JWT token. So these are the commands. First we will create header, then payload. Before we create JWT, let's quickly review the structure of a JSON web token. So here I have ID token and it's JWT. So JWT is made up of three parts: header, and then payload, and then signature, and all are separated by dots. These are just base64 encoded values. If I convert them, then we can read this JSON data as a string. So what we will do is that we will take two JSON objects, header object and payload object. Then we will convert them to base64, and then we will create hash and sign the hash to generate this signature. Then we will join header, payload, and signature by dot. So let's start. First I will copy this. Here we have header, and this is a JSON object which contains algorithm information and type as JWT. In payload I have sub, name, and IAT, means at what time created, and some random data here. Let's copy it and paste in the CloudShell. So for this JSON, this is base64 value, and for this JSON, this is base64 equivalent value. And now let's create this variable string to sign. And for this, first thing we need is this header, base64 version of header, and then payload. But in payload, make sure to remove this equals sign and copy from E to 0 and paste it here. So this is our string to sign. Now let's hash the string using OpenSSL utility, and this is the string which we have to sign using KMS asymmetric key, and this is the command. So it is AWS KMS sign, then which key ID we want. So we will use alias as JWT key, which is here, and what is our message which we want to sign. So this hash string we will sign. Then message type is digest, signature algorithm, and query as signature. We will take output and do base64 decode. So let's copy it and paste here. Now we have signature or signed value from KMS. Now we can join signature, this header and payload to form proper JWT. So let's do that. We have signature joined by string to sign, and finally we will echo final JWT. So let's paste the command, and this is final JWT from here to here. And if I go to jwt.io, I can paste. Looks like it's not copied properly, so I will copy it again and paste it here. Still looks like there is some error. It's not doing proper copy. Okay, it's pasting only till this K. Let's copy this value again and try to paste. And it pasted till X only. Okay, I need to copy all line one by one. and then this line, and then finally this line. I forgot to make it big while running commands, but you can find them on GitHub, so it's fine. Now we have valid JWT, and for this JWT, we have header info, payload info, and now I need to put my PEM key, public key, to verify if this JWT is valid or not. And key we can find here in KMS key section. If I go to public section, I can copy my key, and then I can paste key as it is here, and it's safe to do so because it's public key, and that's the purpose. And after pasting the key, it says signature verified. Now if someone tries to tamper this message, or any value, if basically any value is changed, then again it will start showing error for this signature. It will say valid signature. So we can use this JWT in JWT-based authentication, and that's what the next project which we are going to make, which is JWT Authentication Server. So I will scroll down a little bit, and here, this is the architecture of our server. But before we create JWT-based authentication server, let's understand how JWT-based authentication works. So this is how JWT-based authentication works. Here I have my client or React application, and here I have my APIs, or let's say application server, and then we use some third party or some separate server that is known as authorization server. And here, let's say Cognito is a authorization server. So instead of authenticating at our application server, we authenticate at our authorization server, and this server verifies credentials and returns a JWT, which is signed by private key. And this JWT can be stored in the cookies. And when we make call to our application server can verify validity of JWT by fetching public key from authorization server. So if I go to Cognito, in last step when we created password manager, we saw that Cognito exposes this URL. Here we can find these keys. These keys are in JWK format, but they can be converted into this PEM format. But this is what the essence, that authorization server issues JWT and provides mechanism to verify that JWT by exposing public key. So let's see architecture. So we will have two Lambda functions, sign up Lambda function and login Lambda function. For sign up Lambda function, user can enter username and password, and password will be encrypted and stored in DynamoDB. When user will log in, we will take password from DynamoDB and decrypt it and verify if password is correct or not. If password is correct during login, then we will use asymmetric key to create a JWT token and return to the front end. After that, we can expose one more API which can expose our public key, and our application server can use that public key to verify validity of JSON Web Token. So let's create it in our AWS account. Let's go to code and expand auth server section, and let's see code of sign up first. So in sign up, we can see that we are using symmetric key to encrypt the password and store it in DynamoDB. And this time DynamoDB table name is auth server. And for login, we are using symmetric key to decrypt the password, and asymmetric key to sign the JWT. Let's go and create these resources in AWS, starting with DynamoDB. So search for DynamoDB and create new table. Table name can be anything, but let's keep it as auth server. And this time we will have just partition key, and partition key will be user ID. So each user will be uniquely identified by user ID, and which will be nothing, it will be username. And create the table. After that, let's create Lambda function and IAM role as well. Everything is zoomed. No, it's fine. So let's go to roles, create new role, and this role we are creating for Lambda. For this role, we will attach our own policy. Let's call role as auth server role and create it. Go to auth server role and attach inline policy. For service, select DynamoDB. And let's see what policies are required. So go to auth server, Lambda, not Lambda, IAM role policy and policy.json. So for DynamoDB, we need get and put. Let's select get item and put item. We want for this table, auth server table. So I will copy the ARN and add it here. Next, or previous only, let's add one more permission, and this permission will be for KMS. For symmetric key, we need encrypt and decrypt. So encrypt and decrypt. And for which KMS key we want. So either we can create new KMS key with default settings and key type as symmetric, or we can use existing key. So let's use this existing key, which is a symmetric key, and its alias is pass manager key. Add ARN. Let's add one more permission, and this is also for KMS, but this is for sign and verify. So sign and verify, and for this we need to use asymmetric key. And here this JWT key is asymmetric key, which is just created with default settings. So let's click on it and copy its ARN and use here. Add ARN. Also, one more thing, in our code we are using some other alias for this. We are using alias as auth server key for asymmetric key, and here alias is JWT key. So let's add one more alias and call it auth server key. So now both alias will point to this key, and create the policy. Let's call it auth server policy. Now we have permission for DynamoDB and both keys. let's add policy for Lambda basic execution role. Lambda, or its basic Lambda execution role. Add permission, and done. We are done with IAM. So we have DynamoDB and necessary IAM role to attach to these functions. Now all we need is to create our Lambda functions and upload code there. Before that, let's go to code of our functions and correct the region. So it's US East 1. Make sure to correct whatever region you are using. I will correct here as well. Make sure to cross check key names as well. And then go to terminal, new terminal, and navigate to auth server, and then run create zip.sh, and it will just create zip files. I guess it's in Lambda, cd Lambda, and that we have 2 zip files to upload. Now let's create these 2 functions quickly. Go to functions, create function, author from scratch. Let's call it let's create sign up first. So sign up, and role, we want the role we just created, auth server role, create. And let's see what is handler name for looks like I forgot to save it. Let's recreate that zip. So for sign up, let's see what is name of function. Function name is also sign up. This we need to update in handler. We want to call index.signup function and save it. Also, let's upload our files, zip files. So I will go to correct folder, which is auth server, lambda, and signup.zip. Upload it. Let's create one more function, login, and select the role, auth server role, create function, upload our code, which is login.zip, and edit the handler. I guess it's login only. Yeah, it's login. So let's copy and paste here, index.login, and save. We are done till here. Let's create one API gateway and 2 routes and link those routes to Lambda function. So open API gateway and create API, HTTP API, auth server, create 2 route. Let's see what I'm using in front end. So if I go to front end and login user, I'm using login here, and for create user I'm using sign up. So let's create these 2 routes, and both are post route, login and sign up. For both routes, let's create integration. So create integration, Lambda function, and sign up. No, it's login, so it should be login. For sign up, again create one integration, Lambda function, and this time select sign up. Done. Now we should be able to invoke the APIs. Let's go to API and copy invoke URL. Let's open Postman, paste the API gateway URL, change method to post, and its API gateway URL is slash. First, we need to sign up. So sign up, and in body, let's pass username and password, because in our sign up function, that's what we are reading here, username and password, and then we are calling username as user ID for DynamoDB. So let's pass raw body and pass this username and password, send. Item created successfully. Now if I try to create item again, it will give error. Item exists already because of this conditional expression. It will not create two same user IDs. And if we go to DynamoDB, we have this new username and password, and it's encrypted. Means it's able to access the Asymmetric key. Now let's try to log in and get the JWT. So login, and payload will be same. Let's hit enter, and here user is logged in successfully, and this is the token which I got. Let's go to jwt.io and put the token there. So in token, I have header, I have payload with issue time and expiry time, and here I need to put the key. So for now, I will copy the key manually and paste it here. But as a homework, you can expose this key either by putting in S3 bucket or somewhere. So yeah, with this public key, my JWT is valid, and it will remain valid till this time. After that, we can use some libraries, JSON Web Token library, to check if it's expired or not. Now let's quickly configure frontend also. So this is React frontend, but there is nothing much in it. We have just two routes. Create user route, which is posting the data to sign up route or sign up API, and then we have login user route, which is just posting data to login route. And in home route, if we have token in session storage, then we are showing it, else we are navigating to login or logout. Let's run the application. Either I can log in or create account. Let's create account. Also, let's open inspect. Let's log in as this time. Let's register as test. Password, there is no password policy, so let's put 123, and I got 404 for some reason. Let's switch it to all and again try 404. Okay, I forgot two things. One, I forgot to update invoke URL in .env file again, so it's still trying to post to some old API gateway. And another thing that I forgot is to update this URL in course setting of API gateway. So if I do not do, then it will again give error. Let's paste it here, and till port number. This one, let's let me check what header I am posting. So I'm not posting any header, basically. This is sufficient. Now let's try sign up test 123. For some reason, option call is still failed. Create account. Let's see if I'm sending some header. So request. Let's clear it and try again. Option call failed with course errors, and it was trying to post to this URL, which is TMKE74. Let's cross check it's correct. TMKE74, yeah, it's correct. In course, I guess I should allow content type here, because that will go when I post some data. Even though I'm not sending authorization header, content type is required, I guess. Let's try again. Okay, again, I completely ignored that I need to enable post method here. Now this time it will 100% work. Yeah. User created successfully. Let's log in. Test 1, 2, 3. And login is successful. And I'm storing token in the session storage like this. And since session storage have token, I'm seeing this JWT here. And if I log out, then this JWT will be deleted, and I will be again shown this login or create account screen. So now we successfully created JWT authentication server also, and with this we are done with the content of this course. We learned what is encryption, symmetric, asymmetric keys in KMS, permissions, and how to use with S3 and with Lambda. And we also saw how auditing works. We created 2 mini projects. Now it's time for resource cleanup. So let's delete the resources which we created as part of both mini projects. First, start with KMS, because almost all resources which we created are serverless and will not incur any charge, but make sure to delete all keys, because each key is $1 per month right now. And if you have done rotation, then add $1 more. So make sure to schedule deletion of keys. I will schedule, and all are pending deletion and will be deleted. After that, go to DynamoDB tables and delete both tables. Then let's go in order. Let's go to Lambda. And I guess we also created one S3 bucket. Select all Lambda functions. 4 were created as part of previous password manager. 2 we created, and this KMS we created for permission demo. Let's delete all of them. Let's delete S3 bucket that we created for permissions. Empty bucket first and then delete it. Then go to API gateway and delete both API gateway. And then if you created user for testing permissions, make sure to delete that as well. And also make sure to delete the roles that we created, auth role and password manager role. Then Cognito user pool. And with this, looks like we deleted all the resources. In case I forgot something, make sure to delete them as well. But I guess this is it. We deleted everything. So this is it for KMS course. Hope you find it insightful. If you have any feedback or doubts, do let me know in the comments. Thanks for watching.